Good morning. Today we are going to be looking at area of the circle. And then we are going to be practicing today in class area of the circle and a little more circumference practice. So we're going to continue on with the presentation from yesterday. And there were 3 links that we did not get to look at. And these 3 links prove the area of the circle. So we're going to look at them one by one. And this first one actually is probably the best. So we've got this circle right here. It has a certain radius, and we know that the circumference of the circle equals pi times diameter. Diameter is half of the radius. No, radius is half a diameter. So, all right. So the circumference would be pi 2r, okay? And so what this is going to do is this is going to stretch the circle out like we did for the circumference. Whoop. And we can see now it's a little bit bumpy right now, but we can see that each one of these lengths is half of the circumference. So half of the circumference, 1/2 pi times 2r. And I'm going to look at 1/2 of 2. So half of the circumference is equal to half of 2 is 1 pi r. All right, you don't have to be able to flexibly do this. You should understand that each one of these is half of the circumference because it is half of the circle. Let's put it back. Half a circumference here, half the circumference below. That is where we get this from. So each one of these is r times pi, because each one of these lengths from the top center to the outside is my radius, okay? All right, so you say this is not really a straight line. It's not really a straight line, and this is like half of that. It's half of r. Okay, that's fine, I get that. We have all these white spaces here. I'm just telling you what the length is. But I also see that these are kind of like teeth. So I'm going to move the teeth down. And what do I see? I see a parallelogram now, okay? I see a parallelogram. Right here, whose height is r and whose base is r times r squared. So if I were to look at this, I have parallelogram, area of a parallelogram is equal to base times height. So this parallelogram is telling me the base is r times pi and the height is r. Okay, but I have r times r. Remember, we multiply any number by itself, we are squaring it. 2 times 2 is 4, 5 times 5 is 25. So we can represent r as r squared. So the area of this parallelogram is r squared pi. Or what if I turn it back into a circle? Because I'm trying to derive a formula for area of a circle. Oh my goodness gracious, look what I did there. I have to separate it first. And separate it, turn it back into a circle. Nothing has changed. The total area has not changed. whatsoever. So the area of this parallelogram I have is also the area of this circle. So the area of a circle is equal to r squared times pi, or you will hear it most often as pi r squared. But since this is multiplication, it's commutative, so either way is fine. So area of circle is pi r squared. All right, I want to do something really quick. So I'm going to erase everything, rewrite my area formula. So many of you may have noticed that when I expand this and I put it together, this is very, very bumpy. Well, we can always increase the number of sections. And it gets closer and closer to an actual rectangle. I mean, it's still a parallelogram, but when I put this back into a circle, it's still the same circle it was. It just is divided into smaller and smaller pieces, so we get a straighter and straighter line. Still makes the rectangle. So we have our derived formula. I'm going to make all of this available to you so you can explore the other links. We have to move on with some examples here. We have a butterfly conservatory, and its radius is 18 feet. So from the center to the outside of the circle. The material for the new floor will cost $3.95 per square foot. Okay, so right here I see square foot. So I know I'm not thinking circumference. How much will the floor cost? So we're covering the entire floor. So if I'm thinking about square feet, instantly my brain is going to go area. Okay, so we just derived a formula for area of a circle. So area of a circle is equal to pi radius squared. Do we have all our information? Yes. You guys need to just know that pi is 3.14. My radius is indicated in the picture, it's 18 feet. We have to square that, okay? Eighteen times 18 is 324 feet squared. Whenever you are squaring an unit, you just put the squared right there. Multiply that by 3.14, you get, hold on, there we go, 1,017.36 feet squared. Okay, so that is a more accurate answer. The most accurate answer is pi, 324 pi. This is a more accurate answer, but we actually want to take it up to whole square feet. This is a real world problem. And in the real world, you're not going to walk in Home Depot and say, I need 1,017.36 feet squared of flooring. You're going to say, to cover the whole thing, I'm going to need 1,018. We're not rounding to the nearest whole number because if I get 1,017, that's not enough. Okay, so I do want to get 1,018 square feet of flooring, but it's asking me how much will the floor cost. So we're not done with this problem yet. Okay, So now we need to calculate the cost necessary for flooring materials. So my area is about 1,018 square feet. Well, actually, that's how much tile I need. The area is closer to 1,017 feet. But for our purposes, we're going to use 1,018 feet. So which one of these can I use? It's $3.95 per tile, per. So per equal to multiplication. So I'm going to use this equation right here. Per. So 395 times 2018. It's going to cost $4,021.10. That's not including tax. So that's how much the floor is going to cost. These types of multi-step problems are something you are going to see. Please pay attention. We're going to calculate the area diameter from the area, okay? So the first thing I want to write down is area equals pi r squared. Okay, so I'm going to use that one. I also need to figure out the diameter. Okay, so 2r equals diameter. 2 times radius equals the diameter. I remember that too. So the athletic department wants to paint the school's mascot logo on the gym locker room wall. They start by painting the solid blue circle on the wall. I can see that right there. What is the maximum diameter the logo may have using 1 quart of blue paint? Okay, so from this, we have no idea what's going on because we don't know how much 1 quart covers. But if I see the picture right here, we can see that 1 quart covers 78 and a half feet square. Okay, so if I look at my original equation right here, I have some of this information. I have the area. That's 78 squared. I also have pi. What I'm missing is the radius squared. Okay, so when we have area, that's when things get tricky. We have to start taking roots. So first we need to isolate 3.14. Get that all by itself. Not 3.14, the radius. You have to isolate the radius. That's our unknown. So 78.5 divided by pi, 3.14, is 25. Wow, that worked out really nicely. 25 feet squared is equal to r squared. So we can try to take the square root both sides, but you should recognize that 5 times 5 is 25. So if I take the square root of both sides of this equation, I am going to come up with 5 feet equals my radius. So taking the square root is just what number did you multiply by itself to get that number. I multiplied r times r to get r squared, 5 times 5 to get 25, and feet times feet to get feet squared. So I'm left with this. Okay, so now I have the radius because we're looking for the maximum diameter. So now I'm going to use this equation. I'm going to move this so it's separate and do it in a different color. So I know 2r equals diameter. So I'm looking for my diameter, and I now have my radius. So 2 times 5 feet equals diameter. So 10 feet equals diameter. That is the maximum diameter. And feet is the maximum diameter. Okay. Okay. So calculating area from circumference. Okay, so we kind of did a problem like this yesterday where it was multiple steps. But we should be a little more familiar with our formulas at this point. So we are going to be combining the formula for circumference and the formula for area. Well, not combining them. We're going to be using both of them. So from the circumference, remember circumference equals pi times diameter. We're going to figure out the diameter. Once we have the diameter, we can figure out the radius. Oops. I'm going to use this. Half a diameter equals radius. Once we have the radius, we can figure out the area. Okay. So I'm going to go back and I'm going to use my circumference first. She needs new grass and a circular pen for her chickens. What is the area? Area is my goal, but what do I have to start with? Well, all they've given me is the circumference. This fencing is all the way around the circle, so all I have is the circumference. My circumference is 176 feet. I always know pi. My unknown is my diameter, so I need to isolate d. So if I divide by 3, pi by both sides, I should say, it gets something I can use. This turns into 1. I have 176 feet divided by pi. Oops. Now I get 56.0509. Well, let's go ahead and limit it to the hundreds. So I'm just going to use 56.05. Actually, in this case, let's round it to the nearest whole number. 56 feet. Okay? So now I can use this equation right here. So 1/2 of the diameter equals the radius. I need the radius. I'm going to move this over. Do I have my diameter? I sure do. It's 56 feet. So 1/2 of 56 feet equals my radius. So 1/2 of 56 will be 28. Now that I have my radius, I can figure out my area. I'm going to use that last equation. Area equals pi r squared. Area equals 4 times 28 squared, 28 feet squared. Put that calculation in the calculator. Area of the pen is 2,461.76 hundredths feet squared. Okay. All right, so this is how it's a 3-step process calculating area from circumference, because we have to go from circumference to diameter to radius to area. Okay, let's go to our last problem. All right, how far away can a person live from a radio station? And here it's broadcast if the signal covers a circular area of 40,000 square miles. Write your answer as a whole number. Okay, they are not giving us a picture here. Calculate area with circumference. Well, it actually does not give us a circumference. It is giving us area. But we have to understand what's going on. So I have a radio station. has a circular area of 40,000 square miles, which means the radio station is right in the center. So here is my radio station right here, and it's transmitting 40,000 square miles. The furthest point away from the center right here, and this radio station, is going to be the outside of the circle. So a person can live out here and still hear the radio station. Well, the distance from the center to the outside is our radius. So we have an area and we have pi. We need to figure out what is the radius. So area equals pi r squared. So we are looking for r in this one. Now we can calculate area for circumference down here. What is the circular area? What circular area is covered by the signal if their circumference is 745? Okay. So this is my multi-step problem right here. So we need to figure out the area. If this right here is 754 miles. So what do we need from the area? We need the radius, right? What can we figure out from 754 miles? Well, we can figure out the diameter. Okay, so we have to find, we use the circumference, find the diameter, use the diameter to find the radius, we use the radius to find the area. Okay, so remember this for part A and all of this for part B. This is going to be your exit slip.